We are looking into space, towards the galaxy, a giant galaxy 500 billion kilometers away from us. A very big galaxy, which was suspected to host a supermassive black hole in the very center. 101 years ago, someone discovered a streak of light, which was plasma shooting out of the center of the Milky Way, marking the supermassive black hole. And this is the first ever image of a black hole, released by the Event Horizon Telescope collaboration on April 10, 2019. You've probably seen many images of black holes before, but they were all simulations or animations. But this one is finally real. You may see it like a ring of fire, while light actually goes around the black hole, almost in a circle. It shows plasma orbiting the supermassive black hole at the center of the galaxy M87. The bright region shows where plasma is coming toward us, and since it's traveling near the speed of light, it appears brighter when coming toward us and dimmer when going away. This is called relativistic beaming. From the images, it's not really a full ring. It actually is much brighter at the bottom side. Why is that? This kind of structure can only be formed if something in the source is rotating. It could be the black hole, or the matter around it, or both. Scientists can tell that the plasma is orbiting clockwise. It takes around 2 days for the plasma to complete one orbit. Here, we are looking at the black hole using electromagnetic waves with a wavelength of 1.3 millimeters, radio waves. This was the part of the spectrum used to make the image, because it can show us the features close to the event horizon, and it can pass through the accretion disk and interstellar dust to reach our telescopes. The supermassive black hole in M87 is very active, meaning it's constantly feeding on lots of matter from its growing hot accretion disk. But it also has narrow collimated jets above and below it, here shown in blue, thought to be created by incredibly strong magnetic fields. The jets extend out at least 5,000 light years, and one of them appears to be pointing almost straight at us. Relativistic beaming is again the reason we can see the jet coming toward us in this Hubble Space Telescope image, but not the one going away. Let's have a look at what we would see if we were looking from a different orientation. The warping of space-time around the black hole means we can see light even from parts of the accretion disk behind the black hole. They are lensed above and below the shadow region. But why is the image so fuzzy? The answer is because it's so tiny. The black hole itself is huge, well, supermassive in fact. As measured, the black hole has a mass 6.5 billion times that of our Sun. The actual size of its shadow is nearly the size of our solar system, but located 53.5 million light-years away. Its size from our perspective is only about 40 micro-arcseconds. That's the angle it makes on the sky. It puts us at the very limit of what we are technologically capable of seeing. In fact, to get this sort of resolution, due to the basic law of physics, the diffraction limit, we needed a telescope the size of the Earth. That being impractical, the scientists used 8 telescopes spread across the globe. They all simultaneously observed M87, and as the Earth rotated, that helped fill in the Earth-sized telescope that they were trying to simulate. But M87 was not the only black hole they looked at. They also observed the supermassive black hole at the center of our Milky Way galaxy, Sagittarius A star. It's much closer at around 26,000 light-years away, but also much smaller with a mass only 4 million times that of our Sun. It's also less active, only periodically gobbling up matter, and would have much more variation over time, with matter orbiting every 4 to 30 minutes. Perhaps for these reasons, the image of Sagittarius A star isn't as good, but it still shows the same black hole features, confirming beyond a shadow of a doubt that black holes do exist. The general theory of relativity, published over 100 years ago, is supported again in spectacular fashion in the strongest gravities, and at the limit of our ability to test the theory. These scientists did ridiculous extreme things in pursuit of a goal that seemed impossible, and yet they achieved it.